Why the hell in Tasmania every damn Sunday in spring it's always windy? Greetings, the Astro 30 here yet again, and welcome back to AEL. Now if you're new to this channel, please can go down below and consider subscribing. That'll help me out greatly. Cheers. Got some new PCBs to look at today. It's always like Christmas when I receive a PCB weight box. So I've already gone ahead and cut the tape, and you're probably going to get from the title of this video what this is about. So I'll get the PCBs out. Now I'm going to be reviving the mixer amplifier project that I started over 5 years ago now and never finished, and it was going to be a 25 watt amplifier. I've changed my mind. That project is now completely scrapped. I'm not going to continue on with that. However, I'm going to revive it and do it differently with a different power amplifier and professionally made PCBs. Now I can't give you an ETA of how long this is going to take. Could be a few months, could be 6 months, could be a year. But I will go from start to finish and complete this one. So what I've got here is I've got the main preamplifier board, which is the summing amplifier, the EQ, bass, mid, treb, the master volume, and a headphone socket with a volume control for that separately for monitoring. And this is an input channel. Now the original version of this, I had all 4 channels on one single PCB and then another separate PCB underneath for the input sockets. I've changed the idea here. So I'm going to open this bag first because it's easier to get into than the other one is. And we will take out our PCBs. So what I've done is I've made, and this is a revision B because I already made it last year and I wasn't happy with it. I've made each channel a separate module. As we can see here, we've got the input socket and the potentiometer to control its gain. And it's based on an NE 5534 IC. And it's double-sided, and as we can see, we've got a DC in and a DC out. So the main 15 plus minus voltage that comes in on the control board, the EQ board, whatever you want to call it, summing amplifier, is then passed off out through a DC out, same as this, into here. And then the DC out is then passed to the next input module, and so on and so forth. And the same is also true with the mix in and mix out. So we've got the output of this, which goes to the summing amplifier board or control board, whatever you want to call it. Then there's this extra connection here called mix carry. Now that would then connect to the second input board's mix carry, and so on and so forth. So you can have as many channels or as little as you want. So I've got 5 PCBs. I was only going to do a 4 channel. I'm not sure if I'm going to do 5. Now I'll stick to my original idea. I'll go 4. So that's the PCB, and it's based on the original PCB that I did 5-6 years ago. And it has selectable resistors and capacitors here for setting the gain and the input impedance, etc. And it's really not much more to talk about that. And the distance between the center of the input socket and the center of the potentiometer here is 40 millimeters. I believe it's 40 millimeters, or did I make it 35? 40. So that's the input channel. And you can have as many as you want or as little as you want, as I've said. So I'll put this to the side and we'll look at the control board. Probably might be a good idea to assemble one input channel and the control board at the same time, because I think that would make perfect sense. So it's upside down. So there we go, there's a good look at the control board, which I called in the CAD drawing the EQ board, or actually mixer control amplifier. That's what it says here. And as I was saying, on the input board, we've got the DC coming in off the power supply for 15 plus minus and ground, and DC out, which then goes to your input module and then chained basically. So that's the control board, and each of these pots, I believe, was 30 mil between centers. Correction, 25. I'm not really sure why I did that. I think it was for space compactness. So yeah, it's 25 mil between centers, including between this and the headphone jack. Now, I don't have all the parts to assemble this at the moment, but I will do. Now, these footprints for the 10 microfarad non-polarized and the 22 microfarad non-polarized are huge, larger than they need to be, but that's fine. And this is based on the original preamp that I made six odd years ago. We still have our balanced out, hot, cold, ground, and a preamp out, and a line out, which is just non-balanced. So it takes 4 op amps, one of which is a NE5534, or is it? Yeah, there it is. That was the output buffer one. And that's a look at the bottom. I mean, they're very nicely constructed. So, I mean, manufactured wise. But yeah, that's the plan. I'm going to build these up. So, and the mixing comes in over here off of the chain. So I've made this as versatile as possible. Yes, it's limited now because of board mounted potentiometers that you've only got 25 mil between each center, but I reckon we can still work with that. Now, there is a pot ground here which you then put some of this tin copper wire over the top of the pots. It just helps ground the outside of the pots to the chassis if the chassis is not grounded at the front panel, etc. Just helps with noise pickup. So yeah, I think what I might do is I might go and build both boards. So I'll start with an input channel. I'm only going to build one because there's no point building 4 of them in this one video, and just see where we go from there. So that's the plan. I might do time lapse on the assembly, and then we'll get up to the testing. However, this for me is probably going to be a few weeks away yet because I've got to order parts. But yeah, let's get going. It's a couple of weeks later. I'm not sure exactly how long it's been since I shot the intro to this video, but the parts that I need to actually assemble this mixer preamplifier have arrived. Got a various assortment of pots here, capacitors. It's mainly capacitors and pots, plus the input and output connector for the headphone socket, etc. Now, I did receive a package from JCar yesterday. They sent it in one of these Jiffy padded A4 bags. One capacitor. One capacitor in a padded bag of that size. What a waste! So I ended up calling up the customer sales helpline for JCar, and of course it's outsourced to India, I assume, because an Indian answered, but that's neither here nor there. And they said that sometimes the order may get split between the New South Wales and the Queensland warehouse. Now, honestly speaking, aside from the pots because they came from Ultronics, all these parts over here, you cannot tell me that the Queensland warehouse didn't have one of these capacitors in stock. You also can't tell me that the New South Wales one didn't have half of this in stock. That makes no sense to me. Anyhow, I'm going to get on about assembling this thing. It'll be done in time lapse, I guess, because, well, I can. And you can enjoy watching me assemble some PCBs. So let's get cracking. Right, that's the assembly of the modules almost complete. I've got this completely assembled. Pot still works fine. All the capacitors, 2 transistors and resistors, and the output socket for the headphones is installed. I haven't done the pots yet because I've got to prep them. I've got to actually take each pot out, and I've got to file a little bit off the top here so the solder will stick to it. And then I can solder the pot ground strip across each pot. Some may argue that that's unnecessary, but I'm going to do it anyway. Now, these input channels are designed to mount vertically, so the pot's on top and the socket's on the bottom. So I'll go 1, 2, 3, 4. For some reason I'm missing a 10 nanofarad capacitor, which is a 102, and I didn't get one. Unless I'm missing something and not seeing it, but no, I'm going to have to go out to JK and buy one of those. That's fine, I'm not going to order that online, it's just a waste of time. I could have sworn I put it on the order, but obviously I didn't. So I'll go out and get one of them. Everything else is populated, all I've got to do is put op amps in it and then we can test it. But I'm going to leave the testing of that till tomorrow because I'm actually really tired at the moment because, well, I didn't sleep very well last night. So I'm going to leave this here before I make a huge mistake. And I will admit that this is not the original input board that I was assembling in the first half of this time lapse. I actually accidentally stuck the ground stake on this side where the pot ground was, and in the process of trying to remove the solder out of the hole after I got the pin out, I ended up lifting the pad off. So it's only a blind pad on this side, but yeah, still it looked ugly. So I had to rebuild it off camera. That's fine, I only populated half the parts. I saved all the components that I put on there, including the IC socket. So there's no great loss. I didn't really worry about saving the PCB pin. But yeah, I just thought I'd be honest and say, yeah, I wrecked one PCB. It's lucky I'm building a 4 channel and not a 5 channel because I'm now down a PCB and I've thrown it out. But anyway, that happens. Good morning. Well, it's the next day and I've got the thing completed. I had a good night's sleep. I'm actually quite happy about that because I actually had 4 days in a row of, you know, stuff all sleep. But anyway, it's all completely populated now. The pots are in. It's got the ground strap across the top of the pots. Got some connectors connected to each of the PCBs already made up. I actually made these up like last week for something to do when I was bored. Saves doing it, you know, now because it's easier to quickly test. So I've got my signal generator connector going into the input socket here with a headphone 6.5mm to 3.5mm adapter just shoved in there to open the contact, and the ground is going to the ground post of the circuit, which is near the input anyway. Got the DC supply hooked up, got all the controls set to around about the half mast, and I'm ready to test this thing. Okay, circuit's powered up. We've got roughly 15 volts. I'll just bump that up a little bit so it's the same as the other channel. I mean there. Yeah, cool. So I've got about a 600 millivolt signal going into the input board, and I'm coming out of the preamp out. And just excuse the artifacts in the signal there. It's just the way my oscilloscope probe is grounded to the circuit. It's just picking up some random noise. It's also having a bit of a hard time triggering because the signal only seems to be about 57 millivolts peak to peak, which is kind of small. Yeah. So let me rotate the master control up, and immediately we can see the signal increases. However, that's only 200 odd millivolt peak to peak, which is not a lot. Let me drop that down. I'll turn the input pot up to full, and we've gone off the screen. It doesn't quite look sinusoidal. Looks like it's got a little bit of a little notch there. Let's change the time base and have a look. Yeah, it's definitely got a notch there. It's sort of like flat top and flat bottoming a bit. But we're only getting about 1.4 volt peak to peak out, or about 516 millivolt RMS out, which is less than what we're putting in. So currently it's not working as a preamplifier. I'll just drop the input voltage down. Oh well, that cured the flat topping and flat bottoming. It's just the input module was starting to distort. But still, that doesn't explain why we've got really hardly any amplification there. So next step is I'm going to change the type of the wave to a square wave, which looks absolute junk, but it is what it is. And I'm going to play with the bass pot. Absolutely nothing is happening. Play with the mid-range pot, again nothing is happening. Play with the treble, again it's like dead Jim. Alright, so that does not really help us out at all, Mr. Master. So what is going on here? I don't know yet. So what I'm going to do is I'm going to test the balanced out now. So I'll connect across the hot and the cold pins. Well, the yellow trace is the hot and the blue is supposed to be the cold, and there's supposed to be on the blue trace a 180 degree inversion. In fact, I might go back to a sine wave instead of what we're on. Come on. Okay. We've got nothing. There's nothing there on the second channel. It's completely dead. Alright, well that's a bit of a disappointment. Go with the 500 millivolt. So it looks like I may have a routing issue because there's no missing components here, so I'll remove that. We'll test the normal line out, the unbalanced line out, and see if we've got a signal there, just to make sure. Yeah, we do, but it seems to have about the same amount of voltage gain as the other one, the balanced one, which is only about 323 millivolt peak to peak, which is, again, less than what we're putting in. So I should probably find out what we're actually putting in. So I'll just remove this off the end of the probe, and I'll just probe the input. So directly off the signal generator we're putting in 228 millivolts RMS, or about 666 millivolts peak to peak. And as for what's going into the input of the preamp, if I can get my probe properly situated here, we are putting, who knows, let me just drop that, quite a considerable amount more in. 3.74 volt RMS and 10.2 volt peak to peak, but yet there's only like 292 millivolt going out. Why is it so, as Julius Sundermiller would say? Let's have a look at the schematic diagram for this particular PCB, and also the PCB CAD drawing, just to verify that it's routed correctly. Okay, so this is the front end of the EQ board, and do you guys see what I can see? Well, let me zoom in on that summing amplifier. So this is the summing amplifier here, get something to point with. So this is the summing amplifier here, and that sums all the signals coming off the mix boards together. This should be an inverting amplifier. It's configured as a non-inverting amplifier. This is not really going to be doing anything because we're actually grounding the negative or the inverting pin to ground, pin 6 in this case, and we're not applying feedback to pin 6 either. So in this configuration, this op amp's not really going to do anything. So the signal will have no choice but to really go through this resistor back to here, as long as pin 7's output doesn't bring the signal to ground, but it may be performing some form of attenuation. Also, that's the op amp that's in the active backsandal circuit for the tone control. This should also be an inverting amplifier and is configured as a non-inverting. This is not going to work. So again, the signal path really has only one option to go, and that's through this resistor network, that capacitor, that resistor, and then back out. So we've got like 10 volt peak to peak coming here on the input, and what is it? 323 millivolt basically here. Wah, wah, wah. This is a look at the CAD file for the PCB, and indeed it's wired incorrectly. Pin 6 is going to ground, so is pin 2 on the first op amp. It should be pin 5 and pin 3 respectively, and the inputs being pin 2 and pin 6 respectively. These connections are wired backwards. And we're now looking at this op amp here, which is the balanced driver for the balanced line out. The cold pins on the back side of the IC here. Again, pin 6 is going to ground, which is incorrect. This should be an inverting amplifier on this side, so pin 5 should be going to ground, and pin 5 being the input. So that's also routed incorrectly. And just for something completely different, it's also drawn incorrectly on the schematic. Mother. So that certainly explains a lot. I'm actually going to turn my power supply off. That certainly explains a lot. And I will be honest, I already went ahead last night and tested the circuit whilst you weren't looking, and I've already figured out these problems. I did that because, well, I was impatient. I didn't film it because I just wanted to get it done, and then I was going to film testing it again and giving you the results. It's a good thing I did, because at least it saves me now spending half an hour trying to figure out, scratching my head, why it's operating the way it's operating. And in actual fact, it didn't take me half an hour last night to figure it out, because I looked at it, thought, you know, it's got to be a routing issue, opened up the PCB file for the CAD for this, and looked at this IC's configuration, and instantly saw pin 6 and pin 2 going to ground. And I'm like, oh no. My heart sank at that point, because this was about, I think, $30 including shipping for that, so it's kind of on the borderline of expensive for a prototype anyway. The upshot of it all is I'm going to have to fix those routes, have the board remanufactured as a revision C. This is already revision B, but yeah, I didn't test the headphone amplifier in this section either, but I have tested it last night. It does actually work, and it works fine. So the headphone side works. I will actually test it again on camera in just a minute, but what I'm going to do is I'm going to pop this IC out one and prove my original theory there, that whether or not the signal is just simply passing or bypassing through that op amp, just for, you know, shits and giggles. But first I'll just verify that the headphone amplifier is working on camera. So I'm still connected to the line output, so I will increase the volume control for the headphone amp and just touch the other probe on the socket. And yeah, there we go, we've got an output, and it's actually about twice as much as what's going in. So the headphone amplifier is working. Time to pop this IC out, and yes, the power supply is off. A little bit awkward with capacitors in the way. And I can save most of these components off the board anyway when I have it remanufactured, which won't be for a few weeks yet, but when I get around to it. But I'm not going to take any video of it because, well, it's not really applicable. Okay, let's turn this power supply back on. And exactly the same result. I've just proved my own theory. It's just simply passing the signal straight through. So that op amp, for all intents and purposes, is not actually doing anything. There is one other thing I can do to conclude this video, is I can take that op amp that I've just pulled out, stick it in a breadboard, and then wire 8 wires back to the IC socket where it used to live, and reverse pins 2 and 3 and 6 and 5 respectively around, and see if the circuit now operates correctly. I could also do the same with the line driver, which I might do, but I'm pretty sure that it's going to work. Alright, as fiddly as that was, I have actually got these fly wires jammed into the IC socket. Pins 2 and 3 reversed around and pins 6 and 5 reversed around respectively. And the wires keep popping out, so I've really only got one chance at testing this, and one chance only, before things start disconnecting. Right, you guys can look at the scope screen, turn this power supply on. Bingo. That is a lot better. We got now like 3.65 volt peak to peak coming out, 1.27 RMS. Both volume controls on each board are set to halfway. So if I now play with some pots, I'll play with the input pot. Well, we knew that worked, and we're actually going into clipping now. That's good. Now the master. That's quite good. Actually, how much output is this producing before clipping? Let's turn that right down as far as it goes, which is not very far. So, it's going into the realms of like the 20 volt region, but I can't. I thought the scope went lower than that. No, 5 volts is it. Okay, I might switch the probe to times 10, because it'll make life a lot easier if I can find the switch. There we go. I won't worry about adjusting the scope output. We're just going to have to times that voltage by 10. So there's clipping there. Back it off. So yeah, with the input set back before clipping, 28 volt peak to peak, which is much more acceptable, and that's about 9.9 volt RMS. Excellent. So let's change the scope generation to square wave now, and we'll test the operation of the pots for the EQ, which still doesn't appear to be doing anything. Oh, mid's doing something. Oh, treble's doing something. Let me just drop the volume back off. I'll set it back to times 1. I'll turn the volume right back down. Adjust that. Adjust that. That's about good enough. Now let's see what the bass does. Oh, it's very subtle. You can see that the left hand side of the waveform is dropping down and rising up when it goes to counterclockwise, dropping down when it's maximum. So that's a very subtle change. Mid is giving a right hand peak increase when it's rotated fully clockwise, and conversely ramps down a bit when it's anti-clockwise. And the treble, that's what that does when it's fully clockwise and when it's fully anti-clockwise. So I can see that the tone control network is actually doing what it should be doing, which it wasn't doing before. So I'll go back to a waveform, and I've just realised I'm on 10,000 Hertz, which may be the reason why that may be the reason why I wasn't getting a good response on the bass treble network. That's my bad. Let's try that at 1 kilohertz. It still proves the fact that the tone control network is working, but it's just that I kind of had the wrong frequency. I was testing something else yesterday and I forgot to change it back. That needs to be changed back to a square wave if I can find it. There it is. Now let's try that test again. That's bass, that's much better, that's what I wanted to see. Okay, mid-range, it's different, but that's how that should be operating. And treble, nice. Okay, please forgive my boo-boo there. So that's all well and good. So we know that that is functioning and I don't really need to do any more. So just for a sanity check here, I should probably pull the balanced one out and then just take this wiring from here and just move it over to there and just make the correction and see if the balanced output works correctly as well. I'm going to lose the preamplification because I'm not going to put the IC back in here either. There's no point. I'm not going to like do two sets of wiring, if you know what I mean. I already know that the output from the main preamp is actually functioning as it should if it was routed correctly. So I know when I change those routes, it'll be right. So give me a few minutes, I'll remove all this, remove that, and reconfigure the circuit. Alright, the circuit is reconfigured and I've now replaced the op amp that was in the balance driver circuit and switched pins 5 and 6 around. The others were all correct. Circuit is turned on and look at that. The top trace is the hot pin, which is non-inverting, and the blue trace, the bottom one, is inverting. And as you can see, it is inverting and, well, not exactly the same voltage, but also those noise spikes you can see there are because there's no input op amp in circuit. It's just passing through passively. So yeah, that'll work as well. So even though this particular board is a complete fail, we've learned something out of all this. We've learned how not to use an op amp. Yeah, I'm human, I make mistakes, it just happens. So as I say, I'll just reroute the PCB and fix that issue. I think I mentioned I'll change the footprint size of these bipolar caps. I may not have done, but just make them smaller. This 220 nanofarad capacitor is slightly larger than the footprint that is being devised for it. So I might make that a little wider as well. Other than that, the circuit will remain unchanged. And as I said, I'm not going to take any video of it because, well, the construction of this particular board is going to be the same as the second one. So anyway, it is what it is. Shit happens. I hope you enjoyed this video because I'm going to leave it here. If you did, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying, see ya, have a great day. I'll see you in the next video. It's a shame, but that's just what happens.